All right, guys, we are moving into Chapter 5. We have, again, just a couple weeks before exams. Just so you know, the exam is going to go up through 5-4, so that's our goal for December, just to kind of get through that lesson. So, we got 2 weeks to do it, so we better get started, right? So we have the warm-up here. Again, just as usual, let's give yourself a couple minutes to work through those problems. Again, if you are doing this warm-up before the lesson that I went over in class on constructions, then you probably need to see this explanation for the constructions on 1 and 2. If you're doing it after that lesson, well, then you should be able to do these. Okay, but number 3 you should be able to do no matter what, so you can at least attempt that one. Okay, so number 1, obviously, I'm sitting here on a computer. It's hard to show the actual construction, so what I can do is show the marks and explain the steps to do a perpendicular and an angle bisector. So I'm going to go ahead and do that. Now, I did do constructions before, except that when I did it, it was in preparation for our first quarter exam. So it's the only time we really saw these. I didn't spend a ton of time on it, but we are going to spend a lot more time on it in Chapter 5. So for perpendicular bisector, what you would want to draw first is a perpendicular line. So actually that's what I'll do. I'm going to have, so your first step, and again you just got to follow me here. Step 1 is to have a line, and it has to be a segment, not a line. So I'll call that line segment AB. And when you take your compass, you just got to follow me. You're going to take your compass and put the pointy end at point A. So you put your pointy end on there right now as you're doing it on your paper. And you want to extend your compass so that the arc passes over the midpoint of AB. Now, you don't exactly know where the midpoint is, but you can eyeball it. It needs to be somewhere past halfway and before B. So when you do that, you should be able to draw an arc that looks something like this. Okay, so that would be your arc. I made mine a little, more curved than it probably should be, but you should have an arc that looks something like that. Now take that pointy end that's on A and bring it over here to B, and without changing the length of your compass, draw a second arc. And you should have intersecting arcs. They should touch at 2 points, one above and 1 point below AB. Once you have done that, you have your intersecting arcs, then we're going to want to connect those 2 points using your straight edge. And what we should have constructed is a perpendicular line that bisects, these are my tick marks, that bisects the segment. So that would be how you construct a perpendicular bisector. Obviously, as I look at this, if I was grading this, I'd be looking for the arcs in the appropriate spots, and I want to see these 3 things: the congruent tick marks and your right angle. Alright, next up we had an angle bisector. So again, I'll explain what we would do here. So for an angle bisector, start by drawing any old angle. Doesn't matter what the angle is, we're just going to bisect whatever that angle is. Okay, so in this one, what we'll be doing is we're going to take your, and let's call this angle A, B, and C. Okay, so you're going to, for this one, create a convenient arc on your compass, and that would be like a small arc that doesn't extend too far, but it's not so small that it's hard to use the compass. Sometimes you get the pencil and the pointy end so close together it's hard to really make an arc. So convenient arc, don't make it too big, don't make it too small. And we're going to put the pointy end of your compass right here on B. Put the pointy end on B, and using that convenient arc, draw an arc across your angle so it intersects both edges. Okay, so it looks something like that. Now that you've done that, you have 2 intersection points, and I want you to put the pointy end of your compass on the first intersection point right here, and without changing the length of your arc, I mean you could if you wanted to, but you don't, I would recommend not doing it. You're going to construct an arc somewhere down the middle, just all the way through the middle of your angle. So you're going to have the pointy end here, and it's construct your arc in the middle of your angle. Once you've done that, come over, put the pointy end on the other intersection point on the side of your angle, and construct your second arc. And you should get those two arcs intersecting somewhere obviously in the middle of your angle. So when you do that, you're going to have this point, and you're going to draw a ray through those 2 points. And you need to then label those two angles congruent. And that is how you construct an angle bisector. Again, I'd be looking obviously for the arcs that are made when you construct perpendicular and angle bisectors. Okay, so that's 1 and 2. Number 3, I'm going to find the midpoint and slope of a segment. So we can, and to use this, I'm going to use point slope form. Just kind of giving you that reminder. All right, because I need to find the midpoint and the slope. So let's say the midpoint, not. I was thinking point and slope. I thought point slope, but sorry. Okay, we need to find the midpoint and the slope. So for midpoint, we need to know the midpoint formula. So I'll start here. So midpoint. Remember, midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. So in this case, I'm going to add my x's and add my y's and divide each by 2. So this will be 2 plus negative 4 over 2. That's adding my x values up. Then add your y values up. 8 plus 6 over 2. So this ends up equaling negative 2 over 2. 8 plus 6 is 14, so 14 over 2. And you end up with negative 1, 7 for your midpoint. All right, so we got ourselves a midpoint. Next up, we will find the slope of the segment, and you need to know how to find slope. So I'll keep the same color here. I'm going to come down here. Next up, find slope. And that's going to be y2 minus y1 over x2 minus x1. So in this case, y2 minus y1, I'll do 6 minus 8. Again, I'm calling this, basically in both problems, I'm calling this x1, y1 and x2, y2. So y2 minus y1 is 6 minus 8. x2 minus x1 is negative 4 minus 2. So negative 2 over negative 6, which is positive 1/3 for your slope. So obviously these are some things we'll be using as we move through this chapter and this lesson. So make sure you understand each one of those, especially again those constructions. We'll be doing a lot of those in class, as you'll see if you haven't seen already. Okay. So with that, let's go in. Get into 5.1. 5.1 is on perpendicular angle bisectors. We did some constructions of them already. And the objectives for today or tonight are to prove and apply theorems about perpendicular bisectors. There are going to be a couple theorems we'll be going over in this lesson, and we're going to prove and apply theorems about angle bisectors. So we'll have theorems for both perpendicular and angle bisectors that we're going to need to know. Also have a couple words in here that are going to be new: equidistant and locus. I'll talk about those as we get there. Actually, we'll start about equidistant, talking about equidistant now. So first off, we need to understand what equidistant means, so make sure we're writing down our definitions here. So when a point is the same distance from two or more points, that point is said to be equidistant from the objects. For example, if I have a point P and I have 2 points out here, and they're both the same distance apart, those 2 points, I'll call them A and B. A and B are equidistant from P. So I'll say A and B are equidistant from P. I'll give you a visual to go along with that statement. Okay. So we have a couple theorems here. You're going to want to know these theorems. They're very simple ones compared to some of the things we've done. But the first one is the perpendicular bisector theorem and the converse of it. And what it's basically saying, and you have the whole picture here, but long story short, if I kind of started from scratch, if you draw a perpendicular bisector to a segment, then any point, and this is again the part that you need to understand, any point on that perpendicular bisector to the endpoint of the segment, those segments will be equidistant, no matter where you draw said point on the perpendicular bisector. So these segments would be congruent. I'm just showing you a couple different scenarios. Or I can pick these 2 points way out here. They're all going to be equidistant to one another. Notice I put a different number of tick marks here because not all segments are the same. Just saying, if you pick any random point on your perpendicular bisector, and again you're looking at your picture here, the line I had over here, XY is what I call the perpendicular bisector. That's the line that is cutting AB in half and it's creating a right angle with AB. It's called a perpendicular bisector. Perpendicular and it bisects. Okay. If you put a point on that perpendicular bisector, these segments, those two unique segments that come from that bisector to the endpoints, always going to be the same distance. It actually starts like right here, right? Like that point is on the segment, that's the midpoint, and then as you move up and down that bisector, the segments, yeah, they'll get longer, but if you think about it, if we were doing the proof, I could do Pythagorean theorem on all of these. A, call that B, that's also B because it's a midpoint. So a squared plus b squared is always going to give me the same answer because a and b would be the same. So anyway, we want to know that, and obviously the converse works the same way, just backwards. So I know that if, in this case, if I am given that I have two segments that are equidistant to the endpoints, then that means that line that contains those two segments must be a perpendicular bisector. So if I'm given the other information, I can then state, well, these segments must be congruent and this must be a right angle based on what I was given. So make sure you just understand this whole situation because it works both ways. Okay? Alright, next up, again, just that other vocab word, and then we'll start hitting some examples here. So go a locus. So that's the next phrase. A locus is not, it's an insect, I guess, but it's also a word. It has other meanings or alternate meanings. So in this case, it's a set of points that satisfy a given condition. The perpendicular bisector, as we just talked about, of a segment can be defined as the locus of points in a plane that are equidistant from the endpoints. So if I went back here, all these points that lie on this line, I can make an infinite number of points, right? Those would represent the locus of points that would satisfy this, this theorem. So there's a ton of points. I can put the points up here or there or down here or right there. All these points connected all are going to give you two equidistant segments. So that's called the locus of points. It's the line. Okay. Alright, so let's go ahead and apply this theorem real quick. This can go pretty fast. Example 1 here says find each measure. In this case, we're looking for a TU. Now, what you need to understand is it looks like I have congruent segments and a perpendicular line UW. So this would be the perpendicular bisector theorem, would state that these two segments, UT and UV, are going to be equidistant. So your equation, if you're solving for TU, should be 3x plus 9 equals 7x minus 17. So we're going to solve this up real quick, doing some algebra. Subtract 3x from both sides. So I have 9 equals 4x minus 17. Next, add 17 to both sides. So 26 equals 4x. And then finally divide by 4. So I'm going to get x equals 26 over 4 is going to be 13 halves. You can also say that that is 6.5. I know that 12 over 2 is 6 and 14 over 2 is 7, so it's right in the middle. Okay, but they don't want x. They want the measure TU. TU is a length, so I'm going to go TU equals 3 times 13 halves. I'm going to use the fraction, plus 9. So if we multiply all this out, 3 times 13, that's 26, 39, 39 over 2, plus 9 over 1. I'm going to make that a common denominator of 2. So that'll be 18 over 2. 18 divided by 2 is 9. So that'll be 57 halves for TU. Now again, you can also go the decimal route. It just depends on which answer choice you'd be looking for. Depending, like if you're being tested on it, you can have fractions or decimals. You know, it can go either way. So anyway, if you have 57 halves, I know 56. Like if I did 56 divided by 2, that would be 28. So this would be 28.5. It's in between those two. And 58 divided by 2 would be 29. So it's 28.5. Either answer would be fine. Okay, so again on this, you just want to make sure you set the equations equal, solve for x, and answer the question, find TU. Now, if you accidentally, or you can double check your answer, you can always plug into UV as well, because if you plugged in 13 halves or 6.5 here, you should get the same answer of 28.5. If you don't, you know you probably made a mistake. Now, we have two sets of theorems in 5.1. So we talked about perpendicular bisectors. They also have theorems here for angle bisectors. So here's the things you need to know about angle bisectors. If you have an angle bisector, in this case the angle bisector is PC. And here I'll kind of read it from here too. If a point is on that bisector of an angle, so we can call that point C here, then it is equidistant from the sides of the angle. So that means if I drew two sides or two line segments to my angle, those segments should be equidistant. Now here's the key to this. They don't really mention that in the statement, but you see how they have these right angles in here? Okay, they have to be, these angles have to be congruent in order for this statement to be true. Otherwise, you know, I can draw like this segment, and there's no way this segment is equal to this segment. The angles have to match. All right, you'd be like, what? That's not right. Okay, so the angles have to match. Now they always seem to put, and this is just something, you know, you're just going to see all over the book, they're always going to use right angles. That's probably what you'll see in your exam as well, but the key is in this is they just have to be congruent angles. So as long as these angles are congruent, you're fine. But you're always going to see right angles, you know, so just so you know, they could change that, but I doubt it. So next up, again, you got the converse of that theorem as well. So let's say you're given this information instead of the, hey, we got an angle bisector and all that. If you're given the fact that these angles are congruent and these segments are congruent, then that must mean that C lies on the angle bisector of that angle. And again, as long as you understand this whole situation, regardless, you know, just how they're related, you understand that the you know, the theorem works both ways. The theorem works and its converse works. Okay, so those are the 4 theorems you're going to need to know for 5.1, dealing with perpendicular and angle bisectors. Alright, so we'll knock a couple of these out as well. These are pretty simple examples. Just make sure you understand the concept. Here we're going to find BC. Well, a couple of things you want to know. Looks like we have an angle bisector here. AC is an angle bisector because they gave me the congruent arcs. I see these angles are congruent, therefore I know that these segments must be congruent. So all I would need to do here is just call that 7.2 and be done. So BC, 7.2. Told you this is easy. Yeah, let me make that a little better. 7.2. Okay. Again, you can look at it both ways, it doesn't matter. In this case, we want to find the measure of EFH. So EFH is this angle right in there. Okay, well, a couple things you need to know. I see my congruent segments and congruent angles, so that means that H must lie on the angle bisector. So I know both of these angles are congruent. Well, they told me what the whole angle equals. They said the whole thing is 50 degrees. Well, if I'm looking for EFH, that's one of the angles that was bisected from EFG. So if the whole thing is 50, then I must then know that that is 25 degrees and that's 25 degrees. They have to be equal. 25 plus 25 is 50, right? And they're equal. So the measure of angle EFH is 25 degrees. Pretty simple if you know what you're doing. Okay. And next thing as well, using the same concept, converse of the angle bisector theorem. Okay. We have our two congruent segments and two congruent angles. Notice again, as I said, they're always going to be presented to you as right angles, but they don't have to be. They can just be congruent. I know that KM is now the angle bisector, which means these angles must be congruent to each other. So if I was going to do this example out, trying to find the measure of MKL, I need this guy here. In order to find this angle, I need A. So let's set up your equation to find it. 3A plus 20 equals 2A plus 26. I'm going to solve this for A. So subtract 2A from both sides. So A plus 20 equals 26. Subtract 20 from both sides to get the A by itself. And A is 6. Now that is not your answer. It's just the variable that we're going to use to find the measure of MKL. So the measure of angle MKL, that's going to equal 2 times 6 plus 26, which is 12 plus 26. So that's 36, 37, 38 degrees. As I said before, these are pretty simple if you understand the theorems. Okay? All right, example 3, doing a little application. You know, we still have some problems in here that we're going to need to do some explanations like we did in chapter 4. This is one of those. So this one we have to say John wants to hang a spotlight along the back of a display case. And they're giving you a picture to kind of go along with this. Wires AD and CD are the same length. So let me label that. I got AD, tick mark. CD, tick mark. And A and C are equidistant from B. So A and C are equidistant from B. They're telling you that from B, these are the same length. That's what equidistant means. So how do the wires keep the spotlight centered? So these wires, again, this point, the spotlight's on point D. So all you'd have to do here is explain that, you know, because B is the midpoint of AC and AD is congruent to CD. Again, I'm labeling all this information. Then I know then D, I don't say is, I'll say lies on the perpendicular bisector of AC. So that's the part that we know. Now, so I can now say that's bam here, okay? So they're saying, how does that keep it centered? Well, you know, once you recognize or are able to show that D is on the perpendicular bisector, then you can use the perpendicular bisector theorem. So by the perpendicular bisector theorem, all points on the perpendicular bisector of a segment will always be equidistant from the endpoints of the segment. And again, I'm just giving you my explanation. I know it's easy to just sit here and copy exactly what I say word for word and not even think about it. But you do need to think about it, because these problems, I'm not going to sit here and write them out for you when I'm assessing you on this. What I'm really testing is your understanding of the theorems. Okay, so you need to first be able to tell me, hey, guess what? D lies on the perpendicular bisector of AC. You have to show me how you know that. Once you showed me that, then your next step is to state the theorem and say, well, if D is on the perpendicular bisector, I know by the perpendicular bisector theorem that D will always be equidistant from the two endpoints of that segment. That's how we know those wires are going to keep the spotlight centered, because it's always going to be in the middle. It's always going to lie on the perpendicular bisector if those wires are the same length. So again, there's a lot of ways you can kind of word that, but you're basically going through the same process as I'm going through. So instead of just copying things down, make sure you understand the theorems so you can state them appropriately. Alright, now for some algebra. I really like doing some algebra here. This is one of my favorite ones, which means you may like it or hate it depending on how much you like algebra. But this one says we're going to write an equation in point-slope form. Now again, just so you know, for the test, they're probably going to do this for point-slope form. I hate this form, but y minus y1 equals mx minus x1. Okay, now you know the form that I like to use is y equals m x minus h plus k. So any short answer, I'll take both. Otherwise, you can just move the k over here, because remember, this equals, in my form, y minus k equals m x minus h. Like, these are the same thing. So anyway, we're going to go, I'm going to erase this one. No, I didn't mean to do that. Sorry, my pen's going crazy right now. Good, fix that. Okay, so I'm going to erase this. And again, we're looking basically put it in this form. Okay, and I'm going to use the k and h because that's what I use. And we're going to knock this out. It'll be fun. So we want to write an equation in point-slope form for the perpendicular bisector of the segment with these endpoints. So there are two parts of this that you really need to make sure you understand. We got perpendicular and we got bisector. We have two key components of this problem. So perpendicular means what you think it means. And let me get my color here. I'm going to draw I don't want to do, let's see, that'll work. Okay, I'm going to draw an XY plane. We want to have a picture to go along with what we're doing here. And there you go. And looks like I gotta go at 10, yay. So let's do that. Actually, I'm going to pause this and draw it so you can draw it as well. Unless you're using graph paper, it'll be easy for you to draw. But let's get the picture set up, okay? Okay, so there is our graph and the line segment. And what we're trying to do to this problem is we need to, again, I said there's two parts. We need to find a line that is perpendicular to CD and bisects CD. Well, here's the important part of this, is the word bisector. That's where I'm going to start. Okay, let's focus on the bisector part. I'm going to name each part that I'm doing. Bisector means we need to find the midpoint of DC. Okay, because if I can find that midpoint, then I know that my line will go through that midpoint. Again, when you think point-slope form, what point do you think I'll use for my equation? Probably the midpoint of my segment, because I know the line has to go through it. So the bisector part, we're going to do midpoint. So I'm going to go m equals, I'll call it point m. I haven't used an m yet, so that's fine with me. And I'm going to go, remember, x1 plus x2. If you don't remember the formula, go back to the warm-up when I first wrote it down. But this is going to be 10 plus 6 over 2. And then I'll go 1 plus negative 5 over 2. So that's going to give me 16 over 2 and negative 4 over 2, which means my midpoint is at 8, negative 2. So I'll come up here and label that 8, negative 2 looks good to me. So there's m, 8, negative 2. Okay, so the next part to this, and I'm going to go ahead and draw it right now. This is my line. I don't know if it's actually going through 5, 0. It looks like it, but I don't really know that. But it's perpendicular to CD. So this is where that next step is going to come in. I'll just do it over here. So now I'm going to talk about the perpendicular part. So here's my approach here. I'm going to find the perpendicular slope to segment CD. Again, if I can find the slope of CD, I'm going to find a slope that's perpendicular to that, and that'll be the slope of my line. So again, I found my midpoint. Now I need to find my slope. So again, the way we do that is we find the slope by doing your y2 minus y1 over x2 minus x1. So let's subtract my y values. I'm going to go 1 minus negative 5. So 1 minus negative 5, that's y2 minus y1. Again, if you don't remember the formula, then look it up in the warm-up. So we already wrote it out once before. So I went 1 minus negative 5, and then on bottom I'm going to subtract my x value, so 10 minus 6. So it's going to be 1 plus 5 is 6, 10 minus 6 is 4, and I get 3/2. Now, that's the slope of CD. So the slope of CD equals 3 over 2. Therefore, the perpendicular slope is going to equal the opposite reciprocal. The opposite would be a negative. The reciprocal would be 2 over 3. So that gives me my point, which is 8, negative 2, and now my slope, which is negative 2/3. Coming back up here, now that I have my point and my slope, let's plug this in. My point, which remember I call that my HK, equals 8, negative 2, and my slope is negative 2/3. Let's just plug it in your formula. So I'm going to go y, and I'm going to go y minus k, so y minus negative 2. That's going to be y plus 2 equals m, which is negative 2/3, x minus h, which is x minus 8. There is your equation of a line that is perpendicular to CD. So again, you'll notice this is obviously one of the longer examples, so this is something you want to try to get down. It may take a couple examples to try to get it down. Maybe you have to try this one a couple times on your own to see if you can figure it out. But obviously this is going to be the more heavy algebra laden problems. Some of these other ones are pretty simple if you looked at them. Okay. Alright, so with that we got our lesson quiz, so make sure you give that a shot and fill out your reflections when you're done. Alright, go ahead and give that a shot, and I'll see you guys in class.